For the given function, we want to find the domain, roots, wholes, horizontal asymptote, and vertical asymptotes. To begin this, the first thing that we'll do is find the domain. The domain is your first step because it needs to occur before you do any simplifying of the problem. And the way that we find domain given a rational expression or function, remember a rational expression or function is one where you have a fraction involving x's. So, in order to find a domain with this sort of problem, we always set the denominator equal to 0 to find which values cause division by 0, and we also check if there are any square roots. In this case, because there are no square roots or any type of even root, all we have to do is check what makes the denominator equal 0. So we always start by factoring the denominator, which is already done for us in this case, and then we can set each of those factors equal to 0. When we solve each of them by subtracting 3 and subtracting 2 in each case, respectively, we get x equals negative 3 and x equals negative 2. Which means x cannot equal negative 3 and it cannot equal negative 2. Both of these values would cause division by 0 in the original function, which is impossible. So our domain is all real numbers except negative 3 and negative 2. And we show that using interval notation. We start at negative infinity and we go until our first gap occurs, which is at negative 3. We say that negative 3 is not included, which we show with this union symbol and a parenthesis separating negative 3. And now we continue until our next gap, which occurs at negative 2. And again, we set this up with negative 2 parenthesis union parenthesis negative 2. This means avoid just the number negative 2. And we'll continue on until our next gap, which of course there is no more gap that can occur, so this will go all the way to positive infinity, and this is our domain. Negative infinity to negative 3, union negative 3 to negative 2, union negative 2 to positive infinity. All real numbers except negative 3 and negative 2. Okay, from here we can now simplify the problem now that we've taken care of the domain. So going back to the original function, we have a common factor of x plus 2 in the top and bottom. We're going to cancel that x plus 2 out, leaving us with x minus 1 over x plus 3. When we cancel a factor that's common between the top and bottom, that tells us that we have a whole at that value of x. So if we take that x plus 2 and set it equal to 0, whatever value we get when we solve for x will give us the location of the whole. So we'll subtract 2 from each side, giving us x equals negative 2. So when x equals negative 2, we get division by 0, and because that 0 is also in the numerator, we get 0 divided by 0, which is where a whole occurs. So we'll take this value of negative 2 and plug it into the simplified function, x minus 1 over x plus 3. And that will tell us the y value of the whole. So we'll find f of negative 2 in the simplified function. So we have x minus 1, which is negative 2 minus 1, over x plus 3 is negative 2 plus 3, which gives us negative 3 over positive 1, or just negative 3. So the whole occurs at the point x comma y, in this case negative 2 comma negative 3. The negative 2 we found for x, the function value which is y, is negative 3. From here, we can now move to the roots and then the vertical asymptotes, as those are the next two easiest problems to find. For the roots, we go to the simplified function after we've canceled any common factors. The roots will occur anywhere that the numerator equals 0. So we factor the numerator and set it equal to 0. In this case, it's already factored for us. X minus 1 is completely factored. So we'll set that equal to 0 and solve for x, which means we're going to add 1 to each side, leaving us with x equals positive 1. So x equals 1 is a root of f of x. It's a root of the original function. The vertical asymptotes will be just as easy to find. So the vertical asymptotes occur anywhere the denominator can equal 0 after you've simplified the function. In this case, it's already factored for us, just like the numerator. So we just take our x plus 3 and we set that equal to 0. And if we subtract 3 from each side, we get x equals negative 3. At x equals negative 3, there is a vertical asymptote. So we've now found almost all of the information we need for the problem. The last thing that we have to do is find the horizontal asymptote. And we have a general rule for going about this. There are 3 cases that can happen. The first case is that the exponent of your denominator is larger than the exponent of the numerator. So if we were to multiply out x minus 1 times x plus 2 and x plus 3 times x plus 2 before we simplified anything, the leading term of each polynomial, so the leading term of the numerator, would be x squared. So I'm going to write this over here. Horizontal asymptote. The leading term of the top would be x squared if you multiplied out this entire polynomial. The easiest way to check that is take your x with the largest exponent and multiply it to the other x in your other factor with the largest exponent. In this case, that's just x times x. But for instance, if you had a 2x squared minus x, you would just look at the 2x squared. Okay, so going back to this, we have x times x gives us a lead term of x squared on the top. And again, the leading term in the bottom is just what happens if we take these two x's and multiply them together. We will get x squared again in the bottom. So notice the denominator's exponent is not greater than the numerator, so that eliminates one of our possibilities for the horizontal asymptote. The second possibility is that the numerator's exponent will be greater than the denominator's by 1. And if that were the case, we would have to use long division or synthetic division to find the result. It would give us a slant asymptote. But again, that's not the case. The last case is that if the exponents are equal, notice in this case they both have an exponent of 2, then our rule says we just divide them. The horizontal asymptote will occur at y equals the result of dividing the lead terms. And when you divide x squared by x squared, you're just left with 1. So at y equals 1, there exists a horizontal asymptote. And that solves all of the original information we were looking for in this problem. We found the horizontal asymptote, the vertical asymptote, the root, the domain, and the whole.